If you have been doing software development, or in this case, video game development for a while, you might know or might have come across the concept of dependency injection. Now, what does it mean? Well, if you don't know about it, don't worry because I will explain what dependency injection means with simple terms in just a second. First, I would like to start with a very important point when it comes to dependency injection so that you remain motivated enough to finish watching this video, which is why do you need to know what dependency injection is? Here's where we start in this short video. Dependency injection is a technique that you need to know of if you want to remain a professional developer. Now, why do I say this? If you know about software development, we have tons of principles, right? One of these principles is called solids, okay? Just with capital letters or uppercase. The first S stands for single responsibility principle. That means that every single component in your projects, every single class, every single function, every single variable must have one and only one responsibility. Okay, like I said, this is part of the solid principles. This is the first S. SRP, single responsibility principle. Let me give you an example. If you have a player profile class or structure for that matter, that class or structure should have only data that is related to the profile of this player. For example, the level of the player, the name of the player, the experience, whatever, right? Like the surname, everything related to this player profile. And it might also contain functions related specifically to the profile of this player. For example, how to calculate experience, how to set the level, changing the name, and maybe even leveling up and all of these things. However, if you do something like showing a pop-up when you level up, or tracking some data, right? For example, when you send to the backend information about, hey, this player level up, or even to go, for example, as far as to trigger achievements when you reach level 5. If you do this in the player profile class, then you are violating the single responsibility principle because your player profile is just not taking care only of the player profile data itself. You are doing much more than this. Another example might be if you have a function called calculate experience required for, let's say, a specific level. If you read that function, what do you expect to get from this function? You normally expect to get an integer back that tells you how much experience you need in order to reach one specific level. Okay, that's the only thing, that's the only responsibility this function has. However, if this function does other things, for example, if it has side effects or it actually writes into the player profile the new experience, then it is doing more than just one thing. It is accomplishing more than just one responsibility, which is not great. If you violate the single responsibility principle, then let's say this way, you are not being a professional developer, or at least a sloppy one, which is okay. Everyone does it, me as well. But you need to be aware of this. Now, why is this related to dependency injection? Well, dependency injection is going to help you comply with the single responsibility principle. So how exactly? Well, if you do something like I'm showing you on the screen, you see this piece of code here in the player class. When you level up, you are getting an instance to the backend object and then asking the backend class to send a level up notification, right, to the backend. If you are doing something like this, you are already breaking the single responsibility principle. Why is that? Because this level up function should just do that in terms of the player class it is living in. Now, you are informing the backend about a possible or a level up notification that you want to send, which is fine, but you are not doing just that. There is a hidden operation that you are doing, which is to get a reference to the backend object that you have here through the instance or through the singleton pattern. And here, thereof, you are breaking the single responsibility principle, because this function is not doing only a level up, it is also looking for a reference to the backend component. Okay? You are doing this by invoking the instance property, right? Which is running code in the background, and it might look simple, so it is easy to miss, but you are breaking the SRP here, right? The single responsibility principle. You are just doing much more than that. You are also fetching a reference. So that is not great for many reasons, right? In this case, maybe at some point you want to change the reference from that backend, right? Maybe you want to create some automated tests, right? And in order to do this, maybe you want to implement a mock backend that actually does no communication with a real backend, but rather pulls answers from a file or from a JSON document, right? You might want to change the backend behavior when you do these automated tests, right? And if your code looks like this, it is going to be quite complex, because you will need to be replacing your code, like for example, the accesses to backend instance everywhere in your code. What you're doing here is to depend on a specific implementation, and that is not always great. So this is one way that you are breaking the single responsibility principle. There are more examples. For example, if you are using define object by type, and then you pass the backend type, or if you are asking Unity to get you a component, right, by the get component API. If you do any of this, the problem is, again, that your function or your class is doing much more than it should. Is doing much more than a level up. It is also in charge right now of looking and fetching the right references, right? This is bad for the solid principles. This is why we have something called dependency injection. This technique is going to help you overcome these challenges, right? Dependency injection is going to help you comply with the SRP principle, the single responsibility principle. And not only that, it is also going to help you comply, therefore, with the solid principles. Okay. So if you have used dependency injection, you might have probably imported some common packages like Sinject or even strange IOC. And, those are okay. But at the end of the day, you need to have some awareness about the problems that this type of packages bring to your project. Okay, before we get into the specifics of Sinject and maybe strange IOC, let me tell you my simplified definition of dependency injection. Dependency injection is just a pattern. It is just a system that is going to do something for you. Instead of you taking care of gathering and fetching the specific references to the objects that you need, for example, the backend object, right, in the player class when you need to level up, we're going to ask a system to do this for you. Okay? So basically, you as a developer, whenever you have your player class and you need to do a level up, you don't need to take care about getting the backend reference. You're just going to have it, okay, whenever you need it. So your code is going to look much sexier than that. Okay? It's going to look simpler, and it's not going to be buggy and hard to maintain. Okay? So the goal of dependency injection is to do these things for you. And we do this by having just two main functions. The first function is to keep track of the references to your most important objects. For example, we might have the global backend component. We might also have a logger class, right? That takes care of logging messages into the console or the file, etc. Right? You might have a lot of these objects, maybe as well, like some type of sound management system. Many of these things are kind of global objects, right? So the first function of a dependency injection system is to keep track of those. The second one is to give you the references to these objects whenever you need it, right? Now, if you think about this as a book, I think this is a good analogy. Every book has an index or a table of contents, right? In this table of contents, we have a list of chapters. You can think of these chapters as the objects that we are talking about. okay? For example, the backend or the login file and such. And then at the right, usually, you have the page where you can find these chapters, okay? In our analogy, this will be the memory location to our objects. So you can think of a dependency injection system as a table of contents, just a list of chapters and information about where to find them. So whenever you need information about, for example, how to access the backend, you know where to find it, right? And better yet, this dependency injection system is going to give you this reference for you. You are not going to need to look it up yourself. So the first function of keeping track of your objects, we accomplish this by doing something like this, okay? Basically, we are binding objects in the injector or in the dependency injection system. Basically, what we do is to bind an interface to one specific implementation so that at the end of the day, we can swap these implementations easily if we need to do that. For example, I might want to change the logger from a file to the console if I'm in development mode, or I might want to redirect the login to nothing. In this case, I could just say new logger none, depending on the configuration that we are building to, right? Or if we are doing some tests, we can also just say, hey, I want my I backend to point to a backend file or backend dummy, right? This way we can easily swap all of these references in just one place, and this is key. The second part is to inject, right? To give you the references to the objects that you need in any given point in time, right? In this case, if I need to level up in my player class, what I do is just to declare, for example, for this specific implementation, I just declare a reference to, an I backend object. And I just don't find it, or I just don't go look for it. I don't fetch it. I don't even try. I don't care because it is not my responsibility. I just ask the injector to do this for me. And basically, this is the inject operation, right? Hope this makes sense. The inject operation just gets all the fields that we need injected into your object, okay? In this case, it is going to pass me the right backend implementation. Now, the result is that this class suddenly doesn't have to look for the backend implementation. You see, it is more like an abstract concept. It is an interface. There is no specifics about that. That's it. Now, if you have used Senject or Strange IOZ and such, or if you ever think about using that, let me tell you that I have a big problem with this. Now, I have used these technologies in the past, and I was happy with it until a certain point. What was the problem about? The problem was that I had run into several issues where some components were not being injected correctly, and all of this, yada yada, right? And I said, okay, fine, I will just try to find the root cause of this issue. So I just launched the debugger because, of course, it is open source and such. And the result is that I spent days digging through the code in order to understand it first, and then actually to find the root cause of the problem. So if you think about it, I have spent days, several times, in debugging this shit. Now, how much time did I gain by using a dependency injection system? Probably less. So the net result was that I lost time and frustration and motivation and all of these things. I started probably to age much faster because of this trauma. Now, why do I say this? Is this exclusive to Senject? No, it is not, okay? I think these libraries are great for a starting point, but at some point, if you want to really use something for production code, you need to consider this specific point that I am about to make. These libraries are huge and complex, and a dependency injection system shouldn't be complex. It only has two purposes. First, to keep track of references. Second, to inject these references. You don't need a huge framework for this. Why do I say huge? I just did an analysis on the source code of Senject and guess how many lines of code it has. 26K, as you can see in this screenshot. Is it fun? No, because like I said, you will have some problems, I'm sure of that, and when you need to figure out why, you will spend days finding out the real cause of this. Not only that, if you have to extend it, hopefully not, but if you have to extend it, then it is going to be quite complex because you need to understand the framework. How do you get to understand the framework? Well, in general, by reading the documentation, which tends to be quite huge for such a big project, or by reading code. And if you have to read 26K lines of code, good luck with that, okay? So that is my main problem with these existing technologies, which tend to be probably the most famous for whatever reason. And while they work, whenever they don't, they're going to give you a huge headache because, like I said, they are very complex and a dependency injection system should not be complex. So all of this to say that you need to use dependency injection, or rather you should use a dependency injection system because it's going to let you respect the solid principles of software development. To be more specific, it's going to help you comply with the single responsibility principle and also with the inversion control principle, right? So my 3 rules to choose any package in general, just not dependency injection, are this. Can you read and understand and debug and maintain this package within, let's say, 10 minutes? If not, that's already a warning sign, okay? And you cannot do that with Senject, for example, and with many other libraries, okay? To be fair with Senject. 10 minutes is the threshold that I usually work with, okay? Of course, it depends on the specific library that you are talking about. For example, if you are talking about the source code of Unity and the engine itself, you couldn't do this in 10 minutes, but 10 minutes should be more than enough for one simple thing, which is dependency injection. And Senject, for this reason, fails this test. Okay, so this is my main criteria. Can you do all of these things within 10 minutes? Use this rule when it comes to evaluating any technology for your project. It might be 10 minutes, it might be 5, it might be 1 hour, depending on the specific nature of this framework that you want to evaluate, but you get the idea. You want to keep things simple, stupid, and that is where the keyword comes from. Keep it simple, stupid, right? You don't need to over-engineer things. You don't need to overcomplicate things, right? Because otherwise you're going to run into troubles and you're going to waste days and weeks. And you are probably going to even quit game development if you come up with this, right? So if you want me to teach you how to use dependency injection my way, if you want to see how I use it and how I approach dependency injection in my projects, you can join the 7-day trial for the Unity Performance Task Force, where I will walk you through how I use it, some examples, and you will be able to see the past questions on the live Q&A that I hosted for this specific episode, right? In the week number 25 of the Unity Performance Task Force, you will get access to all of this information in detail, right? About my approach to dependency injection. Like I said, you can join us for a 7-day trial, and you can do this by pressing the link below. It is literally 1 hour of your life that is going to take you in order to level up for the entire rest of your career. I think it is quite worth it. Right, I hope this video was useful for you, and I hope it helped you clarify some of the questions you might have had regarding dependency injection and specific implementations. Just keep to that, really. Keep it simple, stupid. You don't need to overcomplicate things. Only 2 functions. Keep references and inject those references. You can literally do this in one file and in under 150 lines of code. You don't need 26,000 lines of code for that. All right, see you on the task force.